Hello everyone. Welcome to the GEOG361 Lab 8. Before I demonstrate how to calculate, how to answer the question, so first I want to give you a little bit review about how to understand the chi-square distribution. So let's give you one example. So for example, we have some points. Let's say we have 3 points here. And then we use a line to fit these 3 points. Okay, this is the possible fitting line 1, and we also have one other possible fitting line 2. Here we call this line 2, and we call the black one as the line 1. Which one is better? Well, this is a very easy question because our points are here, and line 1 is here, and line 2 is here. So the distance between the line and the points show whether we have a good fitting result. So how to express those in the mathematical way? We can use the sum of square to express the distance. Let's go back to this one. So for this question here, we have 3 points, right? So we may say our sum of distance is .1 minus the corresponding estimated value E1 square plus .2. This is the .2 minus the corresponding estimated 2. Plus 0.3. This one is the 0.3 minus estimated 3. The corresponding estimated point is here. If we calculate the sum of distance for the points as the line 2, we can see the distance between the points and the line 1 is much smaller than the distance between the points and the line 2. So in this way, we can see the line 1 is better than the line 2 to face those points. And also, you may also see here, the denominator has one value. Why we need this one? Remember, when we do the hypothesis test, one of the basic distribution is the standard normal distribution. So the standard normal distribution's average is 0 and the standard deviation is 1. Why we need to relate it with this one? Because our data may have different scale. For example, we have 2 lines here. So let's here. Right? We have 3 points here, and we have one similar distribution. We have 3 points here, right? We have line to face this. We have one line to face this one. So we can see their degree of fitting are almost the same, But if if this value is 1 and this value is maybe 10,000, you can see the sum of distance will be totally different. The sum of distance for this one will be much larger than this one. So we need to divide it something to scale our data. Follows this equation, we just using this square thing divided by the estimated value. This is the basic idea. This is the basic principle of the chi-square distribution. So now I guess you have understand what is the chi-square distribution. So let's go to our question. So first we do the question 1. In the question 1, we have some estimated value and we have some observed value. Okay. The total sample count is 1,000. Then we want to know whether our estimated value can represent the observed value. Let's write down our hypothesis first. So before we write down the non-hypothesis and the alternative hypothesis, I want to just write one and let you guess which this hypothesis should go. So let's see, the observed pattern is the same as the estimated pattern. What do you think? Do you think this statement should go the non-hypothesis or the alternative hypothesis? I will demonstrate to you. So for example, we still have 3 points here, and we use one line to fit these 3 points, right? And here is the distance. Do you think our line is a good line, or actually this line cannot represent those 3 points? So you don't need to answer immediately. Let's draw another situation. So here we have one line and we have 3 points. The 3 points are just underlined. So their distance is 1 and their sum of distance, the distance is 0 and sum of distance is also the 0. So in this situation, we know this one is much better than the first one. So if you plot those things on the chi-square distribution, you may find because they are just the sum of squares, so all the values should greater than 1, right? So you may find something like this. That is the chi-square distribution. So if the chi-square value is close to 0, which means the fitting result is very good. If the chi-square value is very large, which means the fitting result is not very good. So remember when we talk about the significance level, the alpha value is 0.05. It is almost the area from the infinity to some point here. So the area of this, the area from here to the infinity is 0.05. As the area closer to the 0 should be the non-hypothesis. Then let's go back to our question here. So the non-hypothesis should be represented by this part. This part is the observed pattern is the same as the estimated one. After we write down the non-hypothesis, it is very easy to write down the alternative hypothesis. Okay, so next step is to calculate the chi-square value. So this one actually is very easy. We can just follow that equation. The O represents the observed value, and the E represents the estimated value. So let's go to here. The number here is just the observed value. Let's copy those values to Excel, and the total number is 1000. Then we create another column for the estimated value. This doctor estimated the 44% of the cases occur in the winter. So 44% times by 1000 and 36 in spring. I missed one equal notation. Okay, and 7% in the summer. Yeah, I missed that equal notation again. Okay, and 13%. Okay. Then we need to calculate the chi-square score. We just follow that equation. The observed value minus the estimated value square divided by the estimated value. Then we apply this equation to the rest of cells. Okay, then we calculate the sum of square. So this sum equals to sum of this value. So the chi-square is the chi-square is 58.98 something. So the square. So the chi-square value is 58.98. Then we need to figure out the significant value, or the critical value. Sorry. To figure out the critical value, we need to use the chi-square table. So the degree freedom is the k minus 1. The k is the how many samples we have in the data. So in this data we have 1, 2, 3, 4 samples. 4 minus 1 is 3. So we need to figure out some value in this row. The degree freedom equals to 3, and here. The degree of the significant level is 0.05. So we should find some value in this column. So finally, the value we found is 7.81. And we also can see here our calculated value is much larger than the critical value. So we reject the non-hypothesis. Okay, that is answer for the question 1.